Hi, this is the Brassic Gamer. Today we've got a video about this Commodore 1084 video monitor. And this isn't the more popular 1084S. This is one of the Daewoo manufactured 1084Ds, which Daewoo was the second biggest manufacturer of these 1084s next to Philips. And this was a bit of a dumpster find. I found this in a garage of stuff that was going to be chucked out. And, I saw it and I thought, it's a bit yellow and, CRTs take up a bit of space. But just the Commodore logo was enough for me to save it, and I'm glad I did. It's not in bad condition, actually. This little flap here is notorious for breaking and coming off, and that's still, it's still there and working, and got the controls underneath, and turned it on, powered it on, and first problem we had was there was no vertical scan, just had a white line going across the middle, and what it was it must have been the V hold was stuck, or someone had turned it too far and it was stuck in a kind of an underscan or overscan position. So I just kind of unclipped that, and back came the picture. And the first thing I tested it with was a Raspberry Pi, because that's got a composite out. And the inputs on this are you've got RGB, digital or analog. RGB input. Apparently, this monitor is best suited for an A500, an Amiga A500. Or an A1200, so I don't have either of those. I did have a 500, and now I'm kind of sad that I gave it away to someone. But V height, I need to change that because at the moment it's a bit short, but that's fine, we've got that adjustment there. And I've been using the video input for composite input from my Raspberry Pi, and at first I only had a black and white picture. And I thought I might have to open this up and have a look at the, there's a colour sync capacitor which you can look at, which obviously I thought that might have gone, but no, it was just, I had the wrong mode set on the Raspberry Pi, so I just edited the config.txt, and that was all working. So the problem we now have with this is, and I've already started work on this, so I can't show you, but the power button has a mechanical problem with it where it doesn't stay on. So you push it in, and if you hold it, it's on. As soon as you let go, it turns itself off. So I think it's probably dead. So it's a common problem with these, and there's a little bit of documentation online on how to fix it, but I'm going to just show you what the current switch looks like and what we can do to repair it. Okay, so you've got 4 screws to release the chassis. You've got a couple up here, and there's also a couple near the front underneath here. First thing I'm going to say before you opt to take on something like this is, with CRTs you always have to be really super careful. We're not going anywhere near the high voltage parts of it today, fortunately, but they do hold, when powered up, those capacitors can hold up to, well, kilovolts basically. These displays need a high voltage to work properly, and although you only get 240 volts going in, or 110 if you're elsewhere other than the UK, it's you've got some very dangerous voltages in there. So fortunately, this one, well, unfortunately, this case doesn't come off easily. You have to desolder a lead inside, and detach caps and all sorts, and we don't need to do that. We're focusing on this area down here, where you've got the mechanism for the power switch, which is held on with this bracket, which also holds the LEDs. And as you can see, we've just got this spring-loaded mechanism, which unfortunately is clicking in, clicking out, but not staying clicked in. And I've seen a guide. I'll put the because I saw it before I did this. I'll put the link in the comments, but it does tell you where you can order replacements for these. And I did think about repairing it, but as you can see, it's not held together with screws. It's plastic, and it's been melted down, so you can't fix this without destroying it, unfortunately. So, but I look at it and I think, That looks kind of familiar. And because I'm the kind of person who doesn't throw anything away, even stuff that's not working, I've got this old AT power supply. And AT power supplies have usually one of these on them. As you can see, similar mechanism. Clicks in, stays clicked, clicks out. So although it's a similar age, I mean, this is a 1988, 1989 monitor. I don't know if we've got a year on this one. It's probably a similar sort of thing, early 90s, I expect. Same sort of technology. So the best thing about this is you can see the mounting holes are pretty much, I think they probably are the same. So it should be a straight swap. Now, although these have got clips that make them easy to attach, I don't see the same situation here. I need to you need to cut away this protective layer here and just see what's underneath. I'll probably have to clip these wires, strip them, and just kind of tie them around here and then solder them on, and probably a bit of electrical tape or hot glue maybe, just to insulate that. I'll have a look afterwards, whatever the neatest solution is. But as long as we can mount it, and also I don't assume that this switch works mechanically the same as this one or electrically, because I've actually, there's a way you can test, I'll show you what I mean. In order to find out how a circuit works, we want to test for continuity. So if we're measuring 1 at the moment, which means infinite, basically, there is no current flowing. So the circuit, which there isn't one, has infinite resistance. However, let's just connect up our multimeter to this switch, and just to find out how it works. It's a bit fiddly, one-handed. So I've got these two terminals connected with the red and the black, and you need to have as you can see, you need to have yourself plugged into the volts, ohms, milliamps for DC. Rather than for the 10 amps one. So if I click the switch on, oh, that didn't stay on, there we go. So it's, if I'm holding those connected properly, as you can see, it's measuring 0.2 ohms resistance. So that means there is current flowing from that terminal to that terminal when it's on. So if I unclick that, it's then off again. And I can do the same on the other side, and it's the same thing. And but so you've got negative at the back, positive at the front, but this negative and this positive are unrelated. So you've got it's the way the switch works. I'm a bit electronically naive, to be honest. So that's why I test things before I use them, because I have no assumption that I know what it's going to do. And what I need to do here is I've done the same with this switch. I've tested these contacts here just to make sure it works in exactly the same way, because we don't want, we don't want to blow things up. I'm probably talking rubbish, but hey, at least I'm being careful. So I can clip these off, solder it onto there, and fingers crossed we should have a working monitor. Let's give it a go. Okay, so here we have the removed switch. I removed the protective covers, the insulator pads, and the leads were soldered on, which is good news, because obviously if I had to cut the leads, that would shorten the cables, the wires, and that just makes things a little bit more tricky when we come to resoldering somewhere else. I never like cutting wires where possible, and there really is no slack in these things at all. I don't know if it's money saving or what. I mean, if you think about it, if you save, 10 centimeters on each wire, and you're making 100,000, 500,000 monitors, that's obviously going to add up. So they must take these things into account anyway. That's been taken off. Now, the original switch that I tried from that power supply actually didn't work. I turned it on, we had momentary LED activity, and that was it, nothing else. So took it off, tested it, seemed to work fine still. That power supply is working apparently, but fortunately I do have another one, which I got from another power supply, a similar one, And yeah, let's have a go, see if it works. Good news so far, we've got LED activity and got the Raspberry Pi plugged in there. Now, the flicker you can see, I can't see that here, but that can be adjusted. I can't reach the controls right now because of the position of the case, but we have colour and we have a good quality picture. It's flickering a lot, I have to say, but we can probably adjust that. Anyway, that appears to work. Now all I need to do is, I know that in another guide I've seen, buying a replacement switch similar to this, someone had to do a bit of dremeling on there to shave off some plastic and make it fit in the chassis. So I haven't tried that yet, but fingers crossed, it should be alright. I'll give it a go and we'll see in a minute. So it's all put back together again. It's fairly straightforward. There's only one screw that holds that bracket with the power switch into the chassis after you've screwed it into the LED bracket. It's funny because I hoovered up one of the screws that holds it in the other day, but again, because I'm the kind of person who doesn't chuck anything away, this is my random selection of screws I've collected over the years, and I had an almost identical screw in there, so that was handy. So yeah, power switch holds in. Let's plug in the Raspberry Pi. And there we go. Still a bit of flicker, but we can clean that up a bit. Like I said at the beginning, we've got a bit of a band at the bottom and the top there, so we could do with adjusting the V height. But otherwise, there we go. We have now a fully working Commodore 1084, generally regarded as one of the greatest composite monitors you can get. So just need to find that Amiga 500 now. Thanks for watching.